So I am returning to the idea I had of Minesweeper, but it gets more chaotic. So I was thinking I would add urgency via some time-based math. So we start by creating a file for the GUI. Alright, now we import tkinter. We then set up the window. Missed a colon on GUI. Next I will add an attribute to make it the topmost and start its loop. So what this does, it put the window on top so other windows don't hide it. It is useful for small windows. Apparently missed the parent cheese on GUI as well. Next add the GUI to main. I ran it and as you can see we have a blank white window, title cut off in your view due to OBS window capture. So next we create a frame to add our widgets to. Going to put it in the space between title and attributes. We then add it to the grid. Next we make a text box for typing the answer into. For that we need a tk string bar to hold the answer. We put it on the math_frame. Then add it to the grid. Okay, next I am going to add a label for the problem. I will have it above the answer, so I will tweak answer row up to accommodate that. Next let's add a submit button next to the answer. Row 1, column 1. I will make the command just print for now. Using a lambda allows me to pass arguments to the print. So now we are going to make a miscellaneous logic file for some basic logic. Now let's make a function to generate a list of numbers and operations. This first one uses random sample, which has the downside of making them unique, but that can be an upside. Next I make a list of possible operators. Going to keep it to basic arithmetic for now: multiplication, division, addition, and subtraction. So for the number of operations we go with n-1. That way there is an operator for each space between two numbers. So we create a list for the problem in terms of what operator there are. We then use renom.choice to fill the list. Now we can combine these two lists into one problem list. So with the number list it is easy enough, but for the operator list have to account for it being shorter. Now let's go ahead and return the problem list. Then let's do a quick test by running it in main. Remember that tkinter blocks, so it has to be before that. Also we have to import miscellaneous logic. Now we run. Well, we have a problem. I think it is because I enumerated but didn't give two variables to stuff it in, so it packed it together. So it appears to work, but don't like that it just gave. Let's try again and see. Alright, there are difference, also minus is what I meant. Now we make a problem underscore list available by a global scope. Then we go to GUI and update the placeholder text on the problem label to be the problem underscore list. We use an empty string as the separator and use the join function passing our list as an argument. Let's check that it works. So the issue we are having is the join function doesn't support combining strings and integers. To fix this we will use the map function to apply a transformation into a string to each member of the function. 95 is the answer BTW. So let's rework the code so the text form is a global variable it produces called problem text. Silly me, I used miscellaneous logic inside miscellaneous logic. Next we generate an answer. The easiest way to do this is using eval. I will warn to be careful with this function as you want to make sure you have control over any string you eval. So I realized that there can be an exception for division by 0. So figured we would handle that with an exception, same with overflow. We solve both of these by making them give a string instead. We just have to keep this in mind going forward that the solution might not be a number. So now we start working on the submit underscore button. I start by setting it up to receive an answer. That way I don't have to import GUI. So now we test it. I will submit the answer 2 which might be wrong. Alright, it did print 2 so we are good. So next we convert the answer into a float. I put it in a try catch in case we put in a string. I also made a variable to track if it is a float or a string that we are working with since some strings are valid answers, for example when dividing by 0. Sloppy indents. So next we are going to start the process of determining if the answer is correct. To do so I am starting with a new function that takes in the answer we submitted, the answer type and accuracy requirement. The accuracy requirement is useful because sometimes numbers go forever. So I am making it a freebie all the variables not needing some copy-paste math. Also need to import math. I then check if your answer underscore type is a string because if it is and the actual answer is a number you are wrong. Dangled. Now we see how close you were by getting the absolute value of the difference between your answer and the correct one and compare it to our accuracy requirement. Finally, if that isn't the case you are just wrong. So now we need to capture the results. Let's test it out with a simple print statement. Right, so I don't actually set the value on the float in the case that it is not a float. Let's go ahead and default it to 0.0. Covered up the code a bit there. Here is the line I changed. Now we resume testing. Good, it responds well to a letter. Now I will give it a close answer that isn't close enough with 28. Good, it gave a false. Now an even closer answer 28.73. That shouldn't have been false. Maybe if we add more 3s. Alright, debugging. Let's have it print out the answer to start. Maybe my math was bad. One more try on this one. With 28.77. Okay, that was the answer. So I think now I move the parameters for generating the problem over to miscellaneous logic to make them easy to edit. So now let's generate a new problem. We have to pull the problem underscore list from global. Also we will need to update the label. So let's test that out. Alright, we get a new problem each time. I am now going to work on the progress bar. The basic idea is it shows a sort of time limit. Progress bar is part of TTK. Now we use the dot after function on the window to make a timer of sorts. I am going with 10 milliseconds that it updates. So a quick test, it should tick once. Printing in response. Also the bar should exist. Good. Now we pass window through so it can trigger itself. It should now spam oh no doom like crazy when ran. I see, I forgot to include misclogic. Forgot. Next we set up a timer underscore length. It works in milliseconds, so shall we. We also set a time remaining portion. Now on each cycle we decrease time underscore remaining by the progression underscore interval. We pass our progress bar through and step it based on the percentage of time remaining, time underscore remaining over timer underscore length times 100. Let's see how that looks. Easy fix, just have to add the parameter. Now we check if it is less than 0 time remaining, and if so reset the time remaining. I am also going to add a print line real fast. Then we test. So the bar is going too fast. Let's update it also when we reset the time underscore remaining. Maybe we should use set rather than step. So I took some time to debug. Turns out value is the correct version. Let's reset the time when an answer is submitted. Alright, now we will do some comms to have this program talk to others. So I should import /install redis. Then we just send a message with an amount of 1. Alright, we switch code bases and then set up a thread to listen for the battlefield intensity messages. We then increase intensity based on the amount. Finally we set it to start the thread. Also import and install redis. Had to also import threading and json. Now back into MathRaid we add an if statement based on not answer underscore success that sends a message. Also import comms. Sorry, rushing just a bit, missed a colon and parent cheese. Also forgot to import json. Seems I also started the thread too early in battlefield intensifier. Back in MathRaid we also send the intensity increase if the time runs out. Build is a math program that increases intensity if we get a problem wrong or the timer runs out. This tells the battlefield intensifier to make gunshot noises.